All you have to do is look at the craters on the moon, I guess, to realize our solar system is a bit like a giant pinball machine with objects smacking into each other.
Doesn't sound very good when you put it that way either, but what would happen if a massive asteroid was coming our way? Turns out there is a scientist here in the Midwest who has a plan, and it's one that NASA is giving serious consideration right now. Tom Lydon of the Fox 9 Investigators here with that story. And you know what, this sounds a little bit, Tom, like the movie Armageddon.
I think you're going to be shocked by how much it's like Armageddon. And there's no Bruce Willis, but the man in the leading role I think is pretty interesting. Astronomers like to say the odds of any of us getting killed by an asteroid are like winning the lottery. But someone somewhere does eventually win the lottery. And many scientists, including the one you will meet tonight, believe the Earth's numbers will soon come up. It is one of humanity's ultimate questions. What is our planet's future? How will it all end? Will we sow the seeds of our own destruction or fall like the dinosaurs? The answers may truly be among the stars. Chelyabinsk, Russia, 3 years ago. A previously undetected meteor, the size of a pickup truck, explodes in the upper atmosphere with the power of 30 Hiroshimas. So what would happen if we learned that humankind's days were numbered? Most would probably panic, some would party, but no one's got a plan, except for one man. And the Fox 9 investigators have come here to Iowa State to meet Professor Bong Wie, the man who could literally save the planet.
I think it will happen in my lifetime.
Professor Bong Wie runs the Asteroid Deflection Research Center at Iowa State. He's an aerospace engineer who spends his days thinking about Armageddon. And it may surprise you, he's a big fan of that Hollywood movie.
Press the button, Stamper.
That movie has about 167 technical flaws found by NASA engineer.
But Professor Wie knows he can't afford a mistake. NASA is currently tracking some 13,000 near-Earth objects. About 1,600 of these are classified as potentially hazardous asteroids, like the one on Christmas Eve, a mile-long asteroid coming close enough to spook Santa's reindeer, crossing within the moon's orbit. In astronomical terms, a near miss. On Halloween, a 230-foot pumpkin-like asteroid zips by the Earth. Scientists only learning it was coming our way 3 weeks earlier.
So we've only discovered about 10% of the asteroids that can really do significant major global damage.
Yes. Surprise. But that's the fact.
But it's not just asteroids we need to worry about. There's also giant comets traveling in unstable, elliptical orbits in our solar system. These so-called Centaur comets range in size from 30 to 60 miles wide and are known to break apart. Some astronomers now believe it was a runaway chunk from one of these centaurs that became the 6-mile-wide asteroid that killed off the dinosaurs. But even an asteroid much smaller can do cataclysmic damage. The one that created the massive Barringer crater near Winslow, Arizona, was only 164 feet, the size of a yacht. If a meteor that size were to strike Minneapolis, it would vaporize everything within a 3-mile kill zone. A 7-mile burn zone would incinerate the airport and Capitol. Mall of America would be leveled. There would be no Hollywood ending unless Professor Wie gets a knock on his door.
Basically, we have to explode the incoming body.
And that's within 5 years.
That's the only options.
His plan is called the Hypervelocity Asteroid Intercept Vehicle, designed to take out a meteor 100 meters or larger, about the size of a football field.
This is the asteroid. This is a satellite or nuclear device. If we cannot just hit the target with a nuclear device, it will destroy all the detonation electronic device. Too fast.
Too fast.
Too fast.
It won't blow up.
Yeah, it just is more functional, everything. It just melts everything.
Professor Wie's solution involves a nuclear payload launched aboard an Atlas V rocket, one of the most dependable. On final approach in space, the payload is released, and a laser-guided system targets the asteroid. As it approaches, the vehicle separates. A first module is called a kinetic payload, which strikes the asteroid with enough force to create a crater about 16 feet deep. It's followed 1 millisecond later by the nuclear device that explodes within the crater, maximizing the nuke's explosive impact.
So this hits,
Yep.
and 1 millisecond later, the nuke is going off.
That 1 millisecond is enough to sort of arm the nuclear fusing, so it's enough time. Because the whole thing is moving at 10 kilometers per second speed.
That's about 6 miles a second, or 22,000 miles an hour. So the timing margins are incredibly slim. And no one appreciates that more than Professor Wie's team of graduate students crunching the numbers. Josh Leishoft from the Twin Cities is working on the guidance system.
We don't really have room for error. So if our thruster was just misaligned by a little bit, we could miss the 18-meter target, potentially. I'll just say the uncertainties of some of our stuff. So we'll say the thruster's firing. We can't say that they're exactly in this direction, or we can't say our spacecraft is exactly at this orientation. We can only get so close, right?
This is not 100% guaranteed space missions.
So if we shatter it, there could be a whole bunch of debris that hits the Earth. Lots of smaller meteors.
Yes. 140-meter asteroid. Then the worst case, each size of the fragment may be 20 meters.
In other words, save the planet, but a global shower of smaller, city-killer asteroids. And there's a mind-boggling scenario of other variables. So much will depend on what the meteor is made of, whether it's solid or spongy, and how much advance warning we have.
We cannot rely on even 5-year warning. What if we have 1 hour warning?
What if we have one hour warning?
Then whole system should be pre-deployed and waiting in the silo,
And
like ICBM. Then it will take 30 minutes to launch.
We could do it that quickly.
Yes.
How much would it cost?
Good questions. $500 million.
And Professor Wie believes there should be a backup in case the first vehicle misses. So the total project would be $1 billion, an expensive insurance policy. For comparison, it's about the cost of the new Viking Stadium. But then, no one really expects the Vikings to save the planet. The real question is, can we afford to do nothing? It is a human luxury to ponder the stars and consider our fate. It may also become a human necessity.
This is only natural disaster which can be predicted ahead with reasonable accuracy. And also this is only natural disaster which can be prevented.